Not all data can be stored in a pile. Oftentimes, data must be ordered in a sequence to be useful. Python offers several ways to store and work with ordered data. Lists are the most common tool, but there is a smaller, faster alternative: the tuple. We will work in split-screen mode. The left side will contain our code, while the right side will display the output when you run the program. What is the difference between lists and tuples? The quick explanation is that a list contains a sequence of data surrounded by brackets, while a tuple contains a sequence of data surrounded by parentheses. Other than notation, there seems to be little difference between these two. In both cases, you can use the length function to display the number of elements in the sequence. Let's run this code. No difference so far. In both cases, you can iterate over the sequence. To show this, let's iterate over the list of prime numbers, and then the tuple of perfect squares. Then run the code. Again, identical behavior. So how are lists and tuples different from one another? To see the difference, let's display the methods available to the list. Print a line of dashes for clarity. Then display the methods available to a tuple. If you disregard the standard built-in methods, you can see that lists have more methods available to them than tuples. This extra functionality comes at a price. Lists occupy more memory than tuples. To demonstrate this, import the sys module. Sys is short for system, and this module contains a wealth of system-specific functionality. To see the available methods, print the directory for the sys module. The function we are interested in is the getSizeOf function. If you call the help function, you see that this function will tell you the size of an object in bytes. Let's use this function to compare the size of a list and a tuple holding the exact same data. Let's make a list with a variety of elements, and a tuple with the exact same elements. And finally, we will display the size of these two sequences. As you can see, the list occupies more memory than the tuple. When you are working with big data sets, this can be significant. Imagine working with a data set containing 100 million lists or tuples. The bytes quickly add up. Another difference between lists and tuples is that you can add, remove, and change data in lists. Tuples cannot be changed. We say they are immutable. Once you make a tuple, it is set in stone. Knowing that tuples cannot change enables Python to make significant optimizations. For example, tuples can be made more quickly than lists. Let's use a module called TimeIt to see how long it takes to create 1 million lists and 1 million tuples. First, import the TimeIt module. The TimeIt module has a function with the same name, TimeIt. The first argument is a statement containing a command we would like to execute. Here, we will make a short list of integers. Next, we enter an argument with the number of times to perform this command. Let's do this 1,000,000 times. The output of this function will be the time it takes to make 1,000,000 of these lists. We'll repeat this test by making 1,000,000 tuples. Finally, we will display the 2 times. Run. On a relative basis, it took much more time to make the lists than the tuples. Imagine the time difference when working with billions of pieces of data. By now, you should be convinced that tuples are useful. So let's cover the essentials for working with tuples. Tuples use parentheses. To make an empty tuple, you simply type a pair of parentheses. Let's quickly make a few test tuples. Next, let's print these 4 tuples. Then run. What's this? The tuple containing a single element looks different from the others. It looks like a string and not a tuple. That's exactly the case. Test 1 is a string. To make a tuple with just one element, you need to type a comma at the end. If we make the change and rerun, everything is now a tuple. Before we explain the mystery behind the tuple with one element, I would like to show you another way to make a tuple. If you want, you can leave out the parentheses altogether. Like before, to make a tuple with one element, you need to end with a comma. If we print each item and its type, we see that all three tests are in fact tuples. Let's now examine the eccentric behavior of tuples with one element. The reason for this is a feature called tuple assignment. Suppose you are working with a large data set containing 3 pieces of data about each person: their age, country, and whether or not they know Python. Perhaps this data was collected in a survey to study the popularity of Python. We will store the results for each person in a tuple. Here is the information for a single person from the survey. To access the data, it is tempting to extract each piece of data individually. As with lists, you can access elements by index. Our video on lists contains full details on indices. We will print the values to make sure this method is successful. This works, but tuples provide a faster alternative. Consider a second survey. You can assign all elements in a tuple to different variables in a single line. This will assign the first element to age, second to country, and third to knows Python. Python unpacks all the values and assigns them for you. Let's print each value to confirm this works. It does. Tuple assignment explains the need for a trailing comma when making tuples with a single element. According to the rules of tuple assignment, this would assign the string Australia to the variable country. By adding an extra comma at the end, you are telling Python that here you do in fact want country to be a tuple, and you do not want to unpack the values into the variable. Please make sure that the number of variables matches the number of elements in the tuple. We will look at 2 cases. Here, we do not have enough variables to hold all the values in the tuple. Running this causes a value error. Similarly, if you have more variables than elements in the tuple, Python will raise a value error. There is no room for sloppy behavior when working with tuples. If you know a student who is reluctant to use this data structure, please show them this video. It will cure them of their pupil tuple scruples.